Hi students, we're back and we're looking at section 6.2, which is solving radical equations. Right on. And so there are several different types of equations with radicals, and we want to focus on thinking about the problem and the best way to solve it as opposed to memorizing how to do it. And so there are going to be some general steps that work for all types of radical equations, because we have to remember that radical, like square root, is equal to half power. So I've got square root of x is equal to x to the 1/2 power. And so we might also see fractional exponents, and they might not be simply square root or cube root or any other type of root. It could also be a 2/3 power or a 3/4 power or 4/3 power, some unusual exponent. And all of those unusual exponent powers are considered radical equations in this unit. So let's take a look at the general steps of solving these types of equations. So these are our 4 general steps. Number 1, we want to isolate the radical expression. That could also be the rational exponent expression. Then we want to use the reciprocal power. So, for example, 1/2, the reciprocal is 2/1, or we would just say the second power. Square power and square root cancel each other out. So we're going to use the reciprocal power to undo the radical or rational exponent. We're going to take the reciprocal power on both sides of the equal sign, because we have to continue to balance our equation and make sure that it's equal on both sides for always. Then we're going to solve for the variable. And then the next step is check for extraneous solutions. So extraneous, I kind of wrote that a little bit funny, has the word extra in it. And it just means there might be an extra solution, because remember, when we're going to maybe square something, it will create an exponent of 2. And there are usually 2 solutions to that. So there's a chance that we could end up having 2 solutions where only one really works. So we're going to plug the answers back in and make sure that they are actually true. We just want to be in a good habit of checking our solutions, because there are some cases where this just doesn't work. We also have to remember we're looking for the principal square root. And so we want our radicals to be equal to positive numbers, because we're only dealing with the principal square root. We are not dealing with the negatives. Just like when we saw our graphs, and it was the square root graph, you may recall, was only the positive half of a parabola. And so we're just taking half of the answers. We're not doing the positive and negative answers. So let's see how that plays out with some examples. Looking here at example 1, I see that it's the square root of 2y minus 1, that's the radical expression, and then we have plus 5 equals 8. So I need to isolate the radical expression, so I need to get rid of the plus 5. So I will find my equal sign, subtract 5 on both sides. Subtracting 5, I'm left with radical 2y minus 1 is equal to 3. Perfect. It's going good so far. And then I know how to get rid of square root. So square root, I'll get rid of that with square power. So I'm going to square both sides of the equal sign. And the square power cancels out that square root. I don't have to do anything to the inside expression. That radicand just comes out as 2y minus 1. It's only the exponent that cancels, because I could have also thought of this as 2y minus 1 to the 1/2 power, and then when I times it to the 2 power, you can tell half of 2, it becomes just first power. So that's why we're able to do that. This is equal to 3. Oh, I didn't square the 3. It's equal to 9. And then we're going to keep going and solving for y. So to solve for y, it's 2y minus 1. I'll add 1 to both sides. And I have 2y is equal to 10. And when I divide by 2, I get y is equal to 5. Great. Now to check that, I would just do, okay, 2 times 5 is 10, 10 minus 1 is 9, square root of 9 is 3, plus 5 is 8. That checks out. So I did steps 1, 2, 3, and 4. All right, let's take a look at number 2. So here, the radical expression is, oh no. Okay, so here the radical expression is x minus 1. And so it's 9 plus x minus 1. I need to get rid of this 9. So that's a positive 9. I'm actually going to subtract 9 on both sides of the equal sign. When I'm done with that, I'm left with positive rad, so I just write rad x minus 1 is equal to negative 8. And this is a problem. So, let's see we don't notice the problem, and let's see what happens. So I'm not allowed to have the square root of x is equal to a negative number. It has to be equal to a positive. So here I have it equal to a negative. What happens when I solve it? I've got squared. That gives me, I just cancel that, and I have x minus 1 is equal to negative 8 squared is positive 64. And I'll add 1, and I will get x is equal to 65. So when I plug that in, let's try plugging it in and see what happens. So I plug that in, I've got 9 plus 65 as x, so 65 minus 1 would be 64. It's supposed to be equal to 1. 9 plus the square root of 64, that's 9 plus 8 is 1. No, 9 plus 8 is 17. So the answer doesn't end up working out. And so this one has no solution. Sorry. So how would we know we have no solution? When we have the square root equal to a negative number. All right, so we've learned a lot. Let's take a look at some more examples that have different roots, not just square roots. So I'm noticing in number 3 we have a fourth root. So the opposite of fourth root is fourth power. And then I'm looking at number 4, that's not a square root. I see the 3 in the pocket, so the opposite of cube root, which is what that is, would be cube power. So I'm just kind of keeping that in mind as I'm noticing the difference is that they have a number in the pocket. And fortunately, that number tells us the reciprocal power. So looking at number 3, I see the radical expression is 2m plus 1. So I kind of treat that like it's its own variable right now. And it's multiplied by 5 and then minus 1. So we need to undo those two operations. So first we undo our addition with opposite of minus 1 is plus 1. Then I have 5. The fourth root of 2m plus 1 is equal to 15. And then I need to get rid of the 5. So I divide by 5. And then I'm left with the fourth root of 2m plus 1 is equal to 3. So it's really important that we keep that whole expression intact, and then we use just our regular inverse operations and opposite of plus. And we don't want to leave that coefficient outside of the radical because we might forget to take it to the fourth power, and that would end up giving us a wrong answer. So the math becomes easier if we isolate the radical right away, and that's why we just usually do it this way. So now I'm going to get rid of fourth root with fourth power. So fourth power here, fourth power here. On this left-hand side, the fourth power and the fourth root cancel each other out. And all that I have left is 2m plus 1. But on the other side, I have to do that work of calculating. 3 to the fourth power is 81. And now I solve for m. Minus 1. 2m is equal to 80. And dividing by 2, I get m is equal to 40. Let's plug that back in and make sure that it works. So we've got 5 to be the fourth root of 40 times 2 plus 1, 81. So that's going to be 3 5 times 3. And then it's minus 1 is equal to 14. Yes, 15 minus 1 is equal to 14. So I just love to check my answers, especially when it's easy with some of these easier calculations. Cool. Let's take a look at number 4. Actually, I bet you could do number 4 on your own. Ooh, no. So this is third root. So here we're going to learn something kind of special. So I can see I need to isolate that radical. I take away 2. And I'm left with just the cube root of 3y plus 1 is equal to negative 2. And you might be saying, hey, there's no solution to that. But there is a solution to this because this is cube root. So if you recall the domain of our cube root functions, when we were filling in our parent t table, it had -8, -1, 0, 1, and 8. And then we took the cube root of those numbers. And so all that to say, let's see, we got cube root of this, and we had -2, -1, 0, 1, and 2. Which is to say, we can get out negative numbers from inside of a cube root, and we could have negative numbers inside of a cube root. So negatives are not a problem with odd roots. So we have the cube root is equal to -2. We're not worried about the negative with odd roots. And so we get rid of the cube root with cube power. The cube root cancels out, and I'm left with 3y plus 1 is equal to -2 to the third is -8. And it's because we've got that odd exponent, odd powers, that we're allowed to have negatives. So now I'm going to keep going solving for my y. I'll subtract 1. And I'm left with 3y is equal to -9. Dividing by 3, I'm left with y is equal to -3. Let's make sure that that works. So we'll plug it back into the original equation. Okay, -3 times, so I've got the third root of -9 plus 1. That's going to be -8, so the third root of -8 is -2. Plus 2, yes, that does equal 0. So that's great. I love knowing that I didn't make a mistake and that the answer works. Cool. Let's look at a few more examples. Okay, so example number 5. That's going to be a doozy. We notice that x is in this problem more than once. I'm seeing the same thing in number 6. Oftentimes when x is in the equation more than once, it just means that there's going to be more work involved. And I'm seeing that here. The steps don't change. We still want to isolate the radical expression and then use the reciprocal powers and solve for x. But what it's going to look like on this one is a little bit different than what we've seen before. So, get ready.